So now you could understand na, the motto behind this speed control. So actually, then what I was talking about, that this is actually ratio of
Sir, sir, I think it will be better if you can talk without sharing the screen, because when you're sharing the screen, your voice is getting cut off.
now this portion is all right. Now I will just show the screen only now. Just this was some previous talk.
Okay, sir.
Just to give you some understanding. So I can just then I can do this thing. That maybe for a few minutes I will stop presentation and then. So actually now it is all right, no? So actually this is the motto behind this speed control technique, where we will be keeping this E by F ratio, not V by F, actually E by F ratio constant. So E by F ratio means actually EMF to frequency. Now at higher voltages, at higher frequencies, so E and V are almost constant. So I can give you an example. Suppose that the difference between the EMF and the voltage is the leakage impedance drop, stator leakage impedance drop, isn't it? Which is very small in case of these induction machines or any equipment which is feeding the load. Because the series drop, if it is high, then the voltage available to produce flux will be less. So that is the reason that the series elements are lower value, are having the lower magnitude. So the impedance drop is around say 5 to 6% for induction machines. So now if you have a 415 volt machine, huh, and then per phase value 415 by root 3, it is around 239 volt or something, and then 5% of 239 is around 12 volt or something, huh? So then actually this 12 volt compared to 239 volt is almost negligible. So therefore E by F and V by F at those points are almost same. So that is why the terminology is VVVF, variable voltage, variable frequency, not variable EMF, variable frequency. So now the voltage will be varied in such a way that your EMF to frequency ratio remains constant. So this is the motto practically. Okay. So that is why you find that in your drives course also you have learned that when the frequency goes lower, right? When the frequency goes lower, so what is going to happen? That the when we supply the rated torque, right? So the current remains same. So IZ drop does not change too much, because see that what happens to IZ drop, the component of Z R will not change with frequency, only the leakage reactance values will change. So therefore you will find that this 12.5 volt drop, right, which we saw for rated frequency and rated voltage. Now when you give a frequency of say 5 hertz, 10 hertz, like that, say for 5 hertz, right, your leakage reactance will be reduced to 10 times, but resistance remains same. So therefore leakage impedance drop will not change to that extent, right? Say instead of 12.5 volt at rated current at 5 hertz, the voltage drop could be around say 6 to 7 volt, right? Now 6 to 7 volt and the voltage is reduced by 10 times. So what is going to happen? Instead of 239 volt, you get 23 volt or 24 volt, and out of which you get a voltage drop of 6 volt. So this is 25%. So therefore, you see that the EMF which is required to build rated flux will not be available. So therefore, some compensation was required. So that was known as boost voltage, if you remember. So that is why the characteristics V by F actually is not linear. It gets nonlinearity below certain frequency, say around 10 to 15 hertz frequency. It deviates from linearity, and we must give some additional voltage. So that is known as boost voltage, right? So those things are known to you, but I am giving you some recapitulation. So now I go to the screen presentation and actual experiment. Okay. So you see here, this is the title. So I don't see much to display that. The objectives, right? Objectives, you see, this is to study the behavior of inverter fed phase induction. Screen is visible. Huh? Is the screen visible?
Yes, sir.
Okay,
Yes,
okay,
sir.
all right. Now the objectives, you see, this is to study the behavior.
Sir, sir,
Huh,
whenever
huh.
presenting the scheme, your voice is very much interrupting. So it will be, I mean, it will be good if you, I mean, don't
How
share your screen
how
so
to
that
avoid
when.
this problem? Is actually, maybe I can go out and come again, come in again. Huh? So what I
Okay,
do,
sir.
I should rejoin once again. So you see, now it is visible. My voice is okay.
Yes, sir. Continues.
So the objectives, you see, now it's breaking. Eh?
Yes, sir. Continue, sir.
To study the behavior of it's getting echo. I don't know. I should request you that all of you mute your should mute your microphones. That can help to study the behavior of PWM inverter fed three-phase induction motor in VYF open loop speed control mode. Another word, open loop. So this open loop means actually there is no feedback regarding the controlled variable. So here controlled variable is the speed, isn't it? So there will be no feedback, speed feedback, right? Open loops or any other feedback like current, whatever. So then with this we can just see that how the speed can be controlled in open loop mode without having any knowledge regarding the actual speed of the machine. That means with the load the speed can vary. That what I have discussed at the beginning. Maybe between say 4% slip to 0.5% slip to a variation of speeds. Say, if I give you an example, difficult to talk. If I give you an example, like say a 4-pole machine, 4-pole 50 hertz machine, its synchronous speed is 1500 RPM, right? So now at 4% sleep, its speed will be 1440 RPM because 4% of 1500 is
Yes, sir.
60. So, right. Okay.
Yes, sir.
1460 RPM. And at 0.5% sleep, its speed will be actually say around 1499 RPM or something like that. So the speed variation of, you can say, of the order of say হ্যাঁ, হ্যালো। Connection is so very unstable. I provide you the data. Afterwards. Now you go to the circuit diagram. Hello. Hello. Am I audible?
Yes, sir. Continue, sir.
Okay. Because my connection is going out, so that is why I need to check. So this is the circuit diagram. Is it visible?
Yes, sir. Yes, sir, it's visible.
Now, the
Yes,
control signal
sir.
uh, who is talking. Hello? কাজ করো যে unless and until কি করি বলো তো তাহলে? না, পিপিটিটা অ্যাকচুয়ালি শোনো, পিপিটিটা তোমাদের ওই ল্যাব ইনস্ট্রাকশন শিট থেকেই নেওয়া, ওই যেটা আছে সেটাই। হ্যাঁ, এখন ওটা দেখেই তো আমাকে বলতে হবে। এনিওয়ে আমি যে চেষ্টা করছি, দাঁড়া আরেকবার। আচ্ছা আচ্ছা আচ্ছা, ও হো হো, তাহলে বুঝতে পেরেছো। হ্যাঁ 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 হ্যাঁ, ঠিক আছে, দ্যাট আই ক্যান ডু। হ্যাঁ, রাইট। তাহলে হ্যালো, তোমরা শুনতে পাচ্ছ?
হ্যাঁ স্যার, শুনতে পাচ্ছি।
আচ্ছা, তাহলে আর স্ক্রিন শেয়ার করছি না। তাহলে
না স্যার, এইভাবে ভালো হবে।
এখন আর স্ক্রিন শেয়ারিং এ নেই তো?
না স্যার, না স্যার, স্ক্রিন শেয়ারিং নেই।
তাহলে তোমরাও ডায়াগ্রামটা দেখো। হ্যাঁ,
ওকে স্যার।
diagram, I think there, this thing I have already explained that how the experiment setup is made. So now the next is run one procedure. So procedure is make the connections as shown in the diagram. যেরকম আছে ওরকম করে কানেকশন করতে হবে and observe the nameplate of the machines carefully so as that you should know what is your rated current, what is your rated frequency. Unless and until you know, you can if you do not know, so you can provide a current which is much more than the rated current, and the machine might burn. So to understand that how much current I should give, or how much voltage or frequency, so those things you can get from the machine nameplate data. Now in run one, if you see, the first step is that run the three-phase induction motor at different voltage and frequencies at no load. So no load means, actually I have said the two ways. The first one could be that you can uncouple the generator. That is a perfect no load, and where even the rotor inertia is not connected to the shaft. But you can do it in other ways, like say that you can make the armature connection and field connection open for the DC generator. In this case, only the rotor of the DC generator will act as some loading or some extra flywheel load, something like that, which is of course can be neglected. So any of the mode you can take for running the generator, running the induction motor under no load. And then starting from 5 hertz to 50 hertz, you have to vary the frequency 5 hertz to 50 hertz in steps of 5 hertz. That means 5 hertz, 10 hertz, 15 hertz, 20 hertz, like that. You can provide the frequency. And actually, the controller which we have, VIF controller in the laboratory, it calculates automatically the voltage to be impressed based on the rated VIF ratio of the machine. So now then, actually starting from 5 hertz to 50 hertz in steps of 5 hertz, and observe the VIF ratio. So you give a frequency input 5 hertz, so it gives you a voltage input automatically. So there are two modes. One is auto mode, one is manual mode in the experiment. So you can go for always auto mode to check it. In manual mode, you can of course enter any voltage, any frequency. So that will not help you. So to understand the thing, you have to give only frequency input in auto mode, and voltage input will be automatically generated. And you can measure the RMS voltage values also, and then speed and current, because all no load anyway, but you can measure it for your purpose. Okay. Now also people are entering. Anyway, so now in run one is completed. Okay. In run two, if you see, look at your page. Now here the motor is to be loaded at its rated capacity. Rated capacity, how do you check? So you connect the armature terminals and the field terminals of the DC generators, and then actually increase the loading, increase the armature current. So now when you increase the armature current, the induction motor armature current, stator current, you can say, induction motor stator current also will increase. Now when it reaches the rated value, the induction motor stator current, you can understand that it is loaded at rated value. Now here, you have to run the motor at different frequencies, maybe 40 hertz, 45 hertz, 50 hertz. 3-4 frequencies only, because we are interested to take the say linear zone only, say 40, 45, 50, right? Keeping V by F ratio constant. Now, at lower frequencies, I am always telling you that the frequency versus voltage curve is non-linear. So therefore, we will not see an unloaded condition at this moment. It's just to check. Now take all the instrument readings, that voltage, frequency, speed, EDC and IDC. And then this run is finished. This is only 2 runs. This experiment is only for these 2 runs at no load operation and full load operation at higher frequencies, maybe 35, 40, 45, 50, like that. And on the no load condition from 5 Hz to 50 Hz. Now, regarding report, I'm telling you, I'll supply one set of data. Now, that will help you to prepare the report. Now, here the first one in your lab sheet, you will find that lab sheet means the instruction sheet. You will find that the comment on V by F ratio obtained in run 1, especially at low frequencies. So this thing what I was talking about nonlinearity, about boost voltage, etc. So you will find that the V by F ratio, they are not same throughout. Okay, so that thing you can do. And the second is that tabulate the readings obtained from run 2 and calculate torque in each case. So torque you can easily calculate, because output power you can calculate for the DC generator, V into I, right? And DC generator input, you have to divide this output power by efficiency of the DC generator. So normally it is taken as 75% as a whole, which is a gross value, of course, but okay, for calculation purpose it is okay. So you can divide this output power by 0.75. So you can get it, the input power, which is actually the output power of the machine. And then that is equal to omega into T. So then you divide by omega, will give you the torque, right? So you can calculate the torque, and you can plot and see it is written, plot the speed torque characteristics at different load in the same graph. So comment on speed torque curve updates. So you can come to know that what is the speed torque curve, what is nature, linear, nonlinear, etc. And then plot the torque current characteristics at different load also. That means you have calculated torque, you know input current, as you have already taken the readings. So then you can plot torque current characteristics. And the fifth one is plot the frequency versus slip speed curve. So slip speed also you can calculate, because you have measured the speed and you know the synchronous speed. So you can take a difference and get the slip speed, and then frequency versus slip speed. So something was not available. So theoretically, I computed the speed torque curve nature like this. So that's why I'm telling you that when you show the current versus torque curve, sorry, current versus frequency at constant torque. So it looks like this one. So anyway, so we will supply you a data set, and from that you can do all these things. And still, if you don't, if you have some queries, so I'm there, of course. So usually I try to, I'll try to go once or twice a week. Today also I'll try, because although I'm not feeling very all right, let's see if it is possible. I will go. So anyway, so this part is finished. Huh?
Okay, sir.
Just I will ask you if you have some queries, so I can answer them. কোনো কোয়েরি আছে?
না, I guess স্যার কিছু বলছে না তো কেউ।
তাহলে একটা কাজ করো, সেটা হচ্ছে আজকে আশা করি সবাই আসো তোমরা, নাকি?
হ্যাঁ স্যার, সবারই তো থাকার কথা। অনেক
জাস্ট আছে টোকেন সবাই প্রেজেন্ট দিয়ে আজকে তাহলে একটা রোল শিট আমাকে একটু পাঠিয়ে দিও। হ্যাঁ, যে আমি এটাকে কেউ চাইলে আমি প্রেজেন্ট করতে পারবো। ঠিক আছে?
ওকে স্যার।
আচ্ছা, এইটা হলো। আর আমি একটা ডেটা সেট দেখছি, আমি পেলেই তোমাদের পাঠিয়ে দেবো। আর তোমরা কি এই পিডিটা চাও? বেসিক্যালি এটা ওইটা থেকেই নেওয়া, তোমাদের ওই যেটা ইয়ে আছে,
ম্যানুয়ালটা, হ্যাঁ স্যার ম্যানুয়ালটা তো পেয়ে গেছি, যদি একই
ওই
একই রকম থাকে তাহলে দরকার নেই স্যার।
হ্যাঁ এটা ম্যানুয়ালটাই অ্যাকচুয়ালি। হ্যাঁ,
ওকে স্যার।
আমি ভেঙে ভেঙে লিখে দিয়েছি যাতে করে একটু বুঝতে সুবিধা হয়, আর কিছু না। ঠিক আছে।
ওকে স্যার, তাহলে আপনি স্যার ডেটা শিটটা দিয়ে দিন স্যার, তাহলে আমরা স্যার 1 উইকের মধ্যে জমা দেবো, তাই তো?
হ্যাঁ, মোটামুটি 1 উইক ধরে, কারণ আমার ডেটা সেটটা পেলে তার থেকে 1 উইক ধরো, বিকজ দেন ইউ আর অলরেডি ক্রাঞ্চড না।
ওকে স্যার।
যদি এরকম হয় যে আমি 5 দিন পরে ডেটা সেট পেলাম,
না স্যার ঠিক
তখন
আছে।
তোমরা দুদিনে হয়তো অসুবিধা হতে পারে, মানে
হ্যাঁ স্যার।
নট ইন এ হারি, বাট ইউ টেক দ্যাট অ্যানাদার 7 days ফ্রম দ্য রিসিপ্ট অফ দ্য ডেটা সেট।
ওকে স্যার।
আর একটা করবে কি, একটা গুগল ড্রাইভে একটাতে একসঙ্গে সবাই জমা করবে, তাহলে কি হবে না, আমার মানে এত খাতা আসছে তো, সো ল্যাব সিট এন্ড অল, দে আর গেটিং মিসপ্লেসড। তোমরা একজন
তাহলে
আরো
স্যার আপনি একটা আমরা একটা ফর্ম বানিয়ে স্যার ওখান থেকে দিয়ে দেবো,
হ্যাঁ
বা স্যার আপনি একটা
নিয়ে
ফর্ম বানিয়ে দিলে স্যার ওটা আপনার সুবিধা হবে বেশি। আপনি একটা যদি আমাদের গুগল ফর্ম দিয়ে দেন, তো গুগল ফর্মের মধ্যে আপলোড করে দেবো, এসটি স্যার ওইভাবেই
তোমরা
মানে আমাদেরকে।
শেয়ার করে দিতে পারো তো, তোমাদের একজন বানিয়ে আমাকে শেয়ার করে দিলেই তো হলো।
হ্যাঁ তাহলে মানে তাহলে আমাদের কাছে কন্ট্রোল থাকবে। ওকে স্যার, তাহলে তাই করবো, আমরা তাহলে একটাই বানিয়ে দিয়ে
থাকলে
দেবো।
আর ক্ষতিটা কি, একই তো ব্যাপার।
ওকে স্যার। ওকে স্যার।
হুম, তোমাদের তবে খুব দেরি করো না, ওই 7-10 দিনের মধ্যে সাবমিট করে রেখো, হ্যাঁ, তাহলে
ওকে স্যার।
মার্কসটা যেন পাঠিয়ে দিতে পারি। আর
ওকে।
আজকের অ্যাটেন্ডেন্স শিটটা আমাকে তাহলে পাঠিয়ে দিও একটা।
হ্যাঁ স্যার, ওটাকে আপনাকে মেইল করে দেবো।
হ্যাঁ, ঠিক আছে, হ্যাঁ,
থ্যাংক ইউ স্যার।
ওকে।